Okay, today we're going to talk about this section I'm going to call section 1.9, and we're going to talk about some rational equations. We're basically going to revisit some of the rational equations that we've talked about, and then we're going to talk about a new type of inequality that hasn't been discussed, polynomial and rational inequalities. Let's revisit the domain of a rational equation. Basically, the domain of a rational equation needs to be, it can be all numbers except those that make the denominator of a rational expression equal to 0. So here you see I described that for you, that if the denominator of a, that basically saying the denominator of a rational expression cannot equal 0. And so let's look at three examples that I've got down here. This first example is x minus 2 over x plus 2. Well, if you were to look at the denominator, x plus 2, and say, what would make this equal to 0? Then the answer would be, if x equals negative 2, then the denominator would be 0. But the key is realizing that that's what x cannot be. So here you'll see I said x cannot be negative 2. And of course what that means is x can be any number other than negative 2. So you'll notice the interval notation down here. So it can be any number from negative infinity to negative 2, union negative 2 to infinity. So notice basically this is every number on the real number line except negative 2, because notice the parentheses, remember, means that the negative 2 is not included. Now over here I'm going to give you this expression. Now this is not an equation, I'm just giving you an expression, and then I'm showing you a way to rewrite the expression. So you can rewrite this expression on the bottom. If you factor out the x out of the x squared minus 5, on the bottom you get x times x minus 5. Well, if you think about what makes that equal 0, what would make the product of x times x minus 5 equal 0? Well, remember we talked about the 0 factor property. So if x equals 0, then the denominator would be 0. Or if this equals 0, x minus 5, and then what makes x minus 5 equal 0? X equal 5. So those are the values that would make that denominator equal 0. So in other words, those are the values that you must exclude from the domain. So x cannot equal 0 or 5. And the way you exclude two numbers from the domain is you actually have to use three intervals in interval notation. What you do is you say, okay, the smallest number to exclude is 0, so I can use everything from negative infinity to 0, but then I can't use 0, so I do a union, and then I can use any number between 0 and 5, but I can't use 5, so basically the union just kind of hops over 5, and then I can use any number from 5 to infinity. So any of these numbers would work except 0 or 5, and that's what this interval notation tells me. And then here, this one is x over, if I were to rewrite this one, it would be x over, let's factor the bottom, and you get x plus 4 times x minus 4. And let's see, we look at this and say, okay, what makes this denominator 0? So you would set that denominator equal to 0, just the bottom part. And we've done enough of this already, so you can tell that if x equals negative 4, this product would be 0. Or if x equals 4, this product would be 0. So x cannot be negative 4 or 4, because that would make the denominator 0. And again, we want to jump over these two numbers in interval notation, so the smallest number is -4, so we go negative infinity to -4, and then union -4 to 4, and I meant to use capital U here so it would look more like a union, and then union 4 to infinity. So it's everything from negative infinity to -4, then we skip -4 and go -4 to 4, then we skip 4 and go 4 to infinity. And that's how you determine the domain of a rational expression. Okay, we saw some rational equations earlier, and so this is sort of a repeat, but let's go ahead and work a couple of rational equations before we get into the inequalities. Here's a rational equation where you have 12 over x minus 1 plus 12 over x plus 1 equals 5. Now, we've talked about this before. What you want to do is you want to figure out what is the lowest common denominator for these three terms. Well, remember 5 is just 5 over 1. So your denominators are x minus 1, x plus 1, and 1. So the least common factor would be just the product of x minus 1 and x plus 1. Now, I went ahead and mentioned the domain here because obviously if x is 1, then this denominator is 0, and if x is -1, this denominator is 0. So that just tells me that my answer cannot include 1 or -1. Now, I want to take this LCD and I want to multiply this by each term. So here I'm going to multiply it by the first term, 12 over x minus 1. Here I'm going to multiply it by the second term, 12 over x plus 1. And here I'm going to multiply it by the 5. Okay, so now when I multiply it by the 12 over x minus 1, the x minus 1's cancel. And so I just get x plus 1 times 12. And that's what I have there. And then when I multiply this by the 12 over x plus 1, the x plus 1 cancels. Now when I say cancel, they equal 1. And so I just have x minus 1 here times this 12. And then over here, I still have x minus 1 times x plus 1 times 5. I could have done another step there, but I went ahead and just brought it down. Now, x times 12 is 12x. 1 times 12 is 12. Here, x times 12 again is 12x. And minus 1 times 12 is minus 12. Now here, what I did first, the easiest thing for me to do was to multiply x minus 1 times x plus 1. And that actually leads to difference of squares, x squared minus 1. And then, of course, I have to multiply it by 5. Okay, so now let's look at what I've got so far. Here, over on the left of the equal, I can combine 12x and 12x and get 24x. And then the plus 12 and the minus 12 is 0, so that disappears. So 12x plus 12x is 24x. And then over here, if I distribute the 5, 5 times x squared is 5x squared. 5 times -1 is minus 5. So what I have here is a quadratic equation. And of course, to solve quadratic equations, I want to get all of the terms to one side of the equal sign. And so the easiest thing for me to do would be to take this 24x and transpose it over here to this side. And of course, when I transpose it, I get minus 24x. So by moving it, that leaves me with nothing on the left, and then I'm going to have 5x squared minus 24x minus 5 on the right. And then I resort to my factoring technique. So I try to find factors of 5x squared, and the only real choice that I can use is 5x and x. And then the only factors of -5 would be 1, -5, or -1, +5. So I tried factors until I came up with the right factors here. If you check the middle term, here you get 1x, and then the outer product is minus 25x. So minus 25x plus 1x gives me the middle term -24x. And of course 5x times x is 5x squared, and 1 times minus 5 is minus 5. So those are the correct factors. And now you know all you have to do is set 5x plus 1 equal to 0 and solve it. And I just went ahead and gave you the answer here. If you subtract 1 from both sides, you get 5x equals -1, then divide by 5, you get x equals -1/5. over here, if you set x, you also set the other factor equal to 0, x minus 5, you get x equal 5. And now let's compare that with my domain, that where it says x cannot equal plus or minus 1. Well, neither one of these answers is 1 or negative 1, so both answers are correct answers. So we get two answers to this rational equation, and you could plug them in and check them. The negative 1/5 is kind of hard to do, but let's say if you wanted to check the 5, we'd get 12 over 4, which would be 3, and we'd get 12 over 6, which is 2, so 3 plus 2 does equal 5. Now if you want to check the negative 1/5, you're going to have to work with fractions, but it should give you 5 as well if you plug negative 1/5 in here for x and negative 1/5 in here for x, and then simplify it. This left hand side should equal 5. Here's another rational equation, but this one's actually proportion because I have a single fraction on the left equal to a single fraction on the right. And remember, I told you before that when that happens you can cross multiply. So it doesn't really matter which direction I go, but let's say I go this product first, x squared times 5. That way I'll get my squared term on the left, and then I'll multiply, I'll cross multiply this direction. Just a minute, I'll make it work in a minute. There we go. Okay. So I'm going to go this way, okay, 3 times x plus 1, okay, and so I get 3 times the quantity x plus 1, and then distribute this 3 times x is 3x, 3 times 1 is 3, so I get 3x plus 3 on the left, and then when I move the 3x across to the other side, it becomes minus 3x, and move the 3 across, it becomes minus 3, and just go get your quadratic formula, because A is 5, right, and B is negative 3, and actually so is C. C is also negative 3. So if you use those three values in your quadratic formula, because actually if you tried to factor this, it's not going to factor over the real numbers, so you're going to plug these three values into your quadratic formula, and I'll leave you to do that, but make sure that you can get the answer I got, and if not, let me know. But the answer should be 3/10 plus the square root of 69 over 10 and 3/10 minus the square root of 69 over 10 are your two answers. And let's go ahead and shut this down now. And in the next video, I'll finish this section by talking about polynomial and rational inequalities.